Hello, my name is Ellie Bohm, and I'm a first-year PhD student in the CMB program. Today, I'll be sharing my research on understanding how Zika virus causes adverse birth outcomes. You may remember hearing about Zika virus during the 2016 Summer Olympics. Zika was spreading rampantly throughout Brazil, and infection outcomes weren't well understood. There was concern for athletes and spectators traveling to the area because community case levels were at an all-time high. However, Zika wasn't only spreading in Brazil. Zika was spreading throughout South and Central America, and many people were becoming infected. It wasn't until the tail end of the outbreak that Zika infection during pregnancy was officially linked to adverse birth outcomes. Zika infection during pregnancy can cause a wide range of fetal harm. These symptoms, such as microcephaly or small head size, brain and mobility defects, and developmental delays, are collectively known as congenital Zika syndrome, or CZS. The risk of CZS varies by the time of infection during pregnancy. People infected during the first trimester have the highest risk of these abnormalities, but there is a risk in every semester. In all, it's estimated that about 1 in 7 pregnancies infected with Zika virus result in a baby with birth defects. But this rate was not uniform across all regions. After the outbreak, it became clear that the rate of birth defects varied greatly. Microcephaly, for instance, varied between Puerto Rico, the Dominican Republic, and throughout regions in Brazil. The overall rate of adverse birth outcomes, also varied between these regions. Therefore, we asked, do different Zika strains have different capacities to cause fetal harm? Our goal was to directly compare Zika strains from South and Central America in a pregnant mouse model. To do this, we used our established mouse model to compare fetal outcomes in mice infected with Zika isolated in Puerto Rico, Panama, Mexico, Brazil, and Cambodia. We time-mated mice to know when conception occurred and then infected with mice with virus at the end of the first trimester. Mice were then euthanized and dissected 7 days later to assess fetal outcomes. To assess fetal outcomes, we looked at fetus development and structure. As you can see here, resorbed fetuses are not healthy. They have begun degrading and are no longer viable. In our study groups, we saw that there was no difference between our control group and mice infected with Zika Puerto Rico, Panama, or Mexico. However, we saw a significant increase in the rate of fetal resorption in animals infected with Zika Brazil or Cambodia. Therefore, we concluded that the rate of fetal resorption is dependent on the infecting Zika strain. We also assessed intrauterine growth restriction or fetus size. We saw that normal fetuses from Zika Brazil infected mice were significantly smaller than those infected with other Zika strains. This was unique to Zika Brazil and was not seen in the similarly pathogenic Cambodia group. In humans, there are many factors that can affect fetal outcome, and we examined a few of these in our mouse model. We found that there is no correlation between the rate of fetal resorption or size and the level of maternal illness, placenta infection, or fetal infection. So then why are we seeing these differences in adverse fetal outcomes between different Zika strains? We think that more subtle factors are causing this difference, so we designed an experiment that can better understand what's going on beneath the surface. We want to examine gene expression in the placenta because the placenta is a critical regulator in the health of pregnancy. Research also points to different gene families affecting fetal outcome. This may be the case during Zika infection as well. This experiment is underway right now, and we are hoping it provides more information so we can better understand what causes adverse birth outcomes following Zika infection during pregnancy. Thank you for tuning in and enjoy the rest of your research day.